saw from today's opener, when you have congruent figures, they're the exact same size and shape, they're like duplicate images, but as your school reference pointed out, you could look for corresponding sides are the same length and corresponding angles are the same measure. So you're looking for how to line things up. So to summarize, congruent figures are exactly the same shape and size. The whole idea of trying to find corresponding sides is that you could have to flip your image, make the mirror image. That's called reflection. You might need to rotate or turn your image to make it so that it would line up with the corresponding sides. And then you would also have to slide it over to where it is or translate. So translations, reflections, and what's the other one? Rotations are called transformations. So you could do transformations to make one fit over the other in order to judge whether or not they are congruent. You could then do measurements. Go, okay, I think if I take this shape, this trapezoid here, and I rotate it upside down, I think it's going to match up with that one. So that this M to A line segment should be the same length as this B to E line segment. And you can take out a ruler or even do that little thing where you check against the edge of another piece of paper and go, yep, I measured this, and this one is definitely the same measurement as that one. Now across from it, the smallest side, I measured that, and that one is exactly the same length as the other one. And what about those slanted sides? Measure those, and every single one of those slanted sides were congruent for the same measurement. So as you're going through, you could write down the specific numbers, or you could just notch that, yep, I found that that's the same as that, I found that one's the same as that one. And that way it's keeping track that you're checking all the different sides. Now when you want to say that trapezoid math is congruent to trapezoid vest, the symbol is an equal sign with a single squiggly over it. So trapezoid math is congruent to trapezoid vest. I've had some people in the past make an equal sign and then just kind of like make a really like white water rapids or something. But all it is a single squiggly. Squiggly is the only word I can come up with. It's called a tilde, technically, that punctuation mark is called a tilde. But, yeah, you just need one hill and one valley. That's all you need. So that's it for congruency. Congruency is typically easier to determine than whether or not things are similar. Except for the fact that sometimes it's almost like an optical illusion. Sometimes it looks like one triangle is definitely not similar or congruent rather to another triangle because of its position. Like one's got the longer side of the right angle over here, and the other one's got the longer side of the right angle over there. And if it was measured, and they might be exactly the same. So don't just assume just from what you visually see whether or not it's congruent or not. Everyone's got the notes so far with the notation filled in? Bless you.
Thank you.
You're going to need that notation tonight for homework. The equal sign with the squiggly over it. Now, judging whether or not things are similar or not is a little bit trickier. Similar figures are the same shape, but not necessarily the same size. Notice it says not necessarily the same size. It could be that it's an exact duplicate. Anything that's congruent is automatically similar. So to think about whether or not something's similar, I think, can I go to a photocopy machine and make either the exact same thing, a duplicate, or a bigger version? I've had students with vision impairments who needed their materials enlarged. So I'd have to go to the photocopy machine and say enlarge it 150% or something like that. I've had other times when I wanted to fit more onto something, and so I've made a reduced version. And I'm going to show you a sample from just recently I did in another class. Oh, I can't find it that quick as I thought. other times you might want to make a smaller version of something. Found it really quick in the other class today. There, it's not. 107. Put it back in the wrong place, it seems. There we go. So I went to the photocopier, and I made a smaller version. I basically said to the photocopier, give me something that's 75% of the original size. So this used to be full-size worksheet, and instead it gave me a smaller version. So it's similar to the original, it's just shrunken. So to have something that's similar, we went to the photocopy machine, but we might not have said, give me the exact same thing. We might have said, give me a bigger version or a smaller version. If I'm dealing with triangles, I can measure the angles. Or I can measure the corresponding angles, is more precise. So triangles are similar. If their angles are congruent, they have the same 3 angles. They might not be positioned the same, but they have the same 3 angles. But this is not necessarily true for other polygons. If you have a square, and you have a non-square or an oblong rectangle, they both have 4 90-degree angles, but they're not similar to each other. When we get into Unit 8 and deal with things in proportion, keeping the same ratio, then we can do it mathematically and discover it. Now it's more trying to visualize and see if something looks like a bigger version or a smaller version. One way, if you're not good at visualizing things, you can actually make a copy of something, of the smaller of the 2 objects, and as you bring it closer to your eye, it actually will completely cover the other one without any overlaps and such, if it is similar to it. So as you bring something closer, and you leave the bigger version down there, as you get closer and closer, it should cover it exactly. I'm going to try to find, I used to have something with pattern blocks like that. If you took the pattern block and you brought it closer to your eye, you would see that it covers the shape completely. But I got to look for that. In the example we have here, they're triangles. So the triangles, you can measure the angles. So if I was dealing with this triangle, I might just go ahead and measure, this one's a 90-degree angle, and measure over here and find out what this one is. And it happens that it's the same as the one that's down the long leg of the right angle on the other one too. And then I measured this one, let's say, and I found that it was congruent to the one over there. So if these 2 triangles have the same 3 angles, then we can say that they are similar. Does anyone have an idea what the notation is to say that something is similar to something else?
Congruent?
No, you weren't here for that. What is congruent to, bless you, is the equal sign with the squiggly over it. So these aren't equal, they're just the same shape. Want to take a guess on what you think the symbol might be?
Just the squiggly.
Just the squiggly. So I'm not saying they're equal. They could be, but I'm not saying that they are for sure. I'm just saying they're the same shape. So it's just the squiggly, just the hill and the valley. The examples that you have A through E. Now you already made these photocopies. And then someone said, well, what if I had another rectangle that was a smaller version of that rectangle? So go ahead and try to draw in a rectangle F. And the rectangle F should be similarly proportioned as rectangle B. Yes, sir?
For the one above it, does it matter which way you put the squiggly?
It's an actual key on the keyboard, and it has the hill first and then the valley. It's a legit symbol. So if you look at these 1, 2, 3, 4, 5, and now 6 shapes, they're actually all rectangles. But which of those rectangles are similar to each other? Who has an idea of which of these rectangles would be similar to each other? What do you think? A is similar to D. Is that all? Are those the only ones that are perfect squares? C and E. So basically, the notation A is similar to C is also a perfect square, which is similar to D is also a perfect square, which is similar to E is also a perfect square. So the whole idea behind using this symbol is I don't have to try to find all my combinations of pairs. By using the symbol, A is similar to C and D and E, and C is similar to A and D and E, and so on. So they're all sort of connected that way. Now the other example was added in because someone said, well, what if you had other things that are similar? You don't want to just tack it onto that chain that we just made. So instead, this B is similar to the F that's over here. And that would just be separated with a semicolon or with the word and, or something like that, so to be able to differentiate the two groupings. Who thinks they can find things that are congruent in the examples there? So remember, congruent means they have to be the exact same shape, but also the same size. You got something that you think's congruent? Mm-hmm.
D and E.
D is congruent to E. So they're both perfect squares with the same side length, E that's rotated. So D is congruent to E. Did anyone see anything different than that? What did you find?
A and C.
A and C are also congruent. So again, the word and or semicolon would make it clear that you're not saying all four of those are similar to each other. Do you get the idea? Now when you're trying to defend that something is similar or not similar, you can use some of those geometric terms we talked about. Well, that one has an acute angle and the other one doesn't even have any acute angles. Or that one is a pentagon, but that other one is an octagon. So you can use your geometric terms in order to do some of this practice. Yes, sir?
What's on the top? What was
Yeah,
it?
well, I'm going to have to give you those because you're on your phone. So hold on. Any other questions about what we did go over?